Hello algebra students, and welcome back to another video lesson where today we start to explore some solving aspects of these quadratic functions, and we begin to look at how to use square roots to help us solve. And so a lot of notes today, a lot of different examples. Make sure you pause frequently if you need a break. Make sure you're taking notes as well. So I want to play a little bit of a game with you, just to, maybe not a game, but just what number am I thinking of here, right? So what number am I thinking of if I were to ask you about the square root of 49? What number am I thinking of when I say the square root of 49? I have a hunch most of you are going to say 7. Because 7 times 7 is definitely 49, right? When we take the square root of a number, when we do this square root, we are looking for some number times itself. That gave us that. But here's my challenge. Couldn't I also have used a negative 7 times negative 7? Negative 7 times negative 7 could have given me the 49 underneath. And so in reality, we actually have two numbers that satisfy the square root of 49, 7 or negative 7. X squared equals 100. What number am I thinking of when I think of x squared equals 100? Well, what number times itself? Many of you probably said 10 times 10. Which is true. 10 times 10 is 100. But again, isn't negative 10 times negative 10 equal to 100? So I, again, in reality, have two answers here. 10 squared is 100, as well as negative 10. And that's a principle that we have to start to understand as we begin to solve some of these square root problems. And there's really three ways to attack solving square root problems. The first one is by graphing. So I'm on page 12 of your packet, where we're going to solve 32 equals 2x squared. That's what we're going to solve by graphing. And so we're going to need to go to Desmos, and we're going to need to graph two different lines. Y equals 32 and y equals 2x squared on Desmos. All right, and we want to make sure that we can have the window to be able to see certain things, where we might have to look for intersections. We're trying to figure out how many times do these two intersect. So let's pull up our Desmos calculator. Y equals 32 and y equals 2x to the second. Now you'll notice my y equals 32. I gotta change my y-axis from, say, negative 2 up to, say, 35, because my y line, that red line, is at 32. Right? That's what we're trying to figure out where it equals. So how many times do they intersect? They intersect twice. Where do they intersect? At those 2 points. So let's just take a quick picture of that and bring that over to our Jamboard for class notes. And let's paste it right here. How many times do they intersect? Twice. What are the x values of the intersection? Well, the x values are negative 4 or positive 4. Negative 4 or positive 4. And so if I were to truly solve that by hand instead, I would divide both sides by 2 to get x squared equals 16. And as we just did on our previous slide with what number am I thinking of, what could we put in here for x and square it to get 16? Both positive 4 or negative 4. So you'll notice that if we solve it correctly or graph it correctly, we should get the exact same answer. What's the intersection in the left quadrant? Well, we got -4, 32. Meaning, if I plug in -4, I should get out 32, which is what this is saying. And same thing in the right quadrant. If I plug in 4, I get out 32. So that's how we can graph, right? We can say y equals this side, y equals this side, and graph them together on Desmos. Now we can do a similar process from a table, right? From a table, y equals -2x squared, and a student made the table for us. So we changed the problem slightly. Y equals -2x squared, and they made a table for us, and we're going to assume their table is correct. They're going to ask us, though, what are the solutions to -18 equals -2x squared? So if you look at this and you look at that top equation, -18 replaced the y. So they want to know when they evaluated, when they plugged in a bunch of different x values, when did they get out -18? We got out a -18 here, and we got out a -18 there. So what were those x values? -3 or 3. -3 or 3 are the solutions, meaning when I plugged those in, when I plugged them in for x, we got solutions that were -18. Here's another one. Give this one a try by making a table of values and see if you can't figure out when does 3x squared equal 12. All right, I made a quick table from -3 up to +3. All right, and we're trying to figure out when it equals 12, so I'm going to plug them in to this part over here. -3 squared is 9, and 9 times 3 is 27. -2 squared is 4, and 4 times 3 is 12. So that's one of them because I got an output of 12. If I plug in -1, -1 squared is +1 times 3 is 3. If I plug in a 0, I get 0 times 3 is 0. If I plug in a 1, 1 squared is 1 times 3 is 3. If I plug in a 2, 2 squared is 4, 4 times 3 is 12, which means that's another answer. And if I plugged in the 3, I should get 27. So that means that the solutions are x equals -2 or 2. By plugging in -2 or 2 into this function, we should get that as an answer. Now, those methods are precise, they work. They're just a little bit more time consuming. We do have some more efficient methods that involve solving by algebra. And you got to be careful and think about how many answers you really should have in these problems, especially if we were to try and graph these, right? We're going to get 2 answers. You know, for example here, a squared is 36. Well, as we've been looking at, we know that I could plug in 6 squared to get 36, or we could plug in -6. And that process is to take the square root of both sides. But before we can do that, we have to isolate the squared element. And so these are the steps that I want to share with you in solving these equations that have x squared. We need to focus on isolating the x squared, meaning I need to move everything else to the other side so that the only thing I have left on one side of the equation is x squared. When I do that, I'm moving the constants to the other side. So those are numbers that don't have a variable. Then I'm going to divide by the a value to both sides, if there is one. That's going to leave me with x squared equals some number, just like we had x squared equals 36. And then we're going to take the square root of that number and make sure that we have both a positive and negative value. And we could check that by substituting it back into the original problem. Those are great notes to maybe pause the video and write down. All right, so let's put that into practice. Again, we already did number 1 on the other slide. We're going to do it one more time. The a squared element, or x squared, this really should be an x squared, is by itself. So we take the square root. X equals 6 or -6, right? That square root of a value is both it's positive and it's negative. Now in number 2, we don't have the squared part isolated. I'm just going to put like a little circle around it. That's not isolated yet. I still have a +1. I need to subtract 1 from both sides so that we have b squared equals 16. Now the squared element is isolated, so that's all by itself. We take the square root. What's the square root of 16? It could be 4, or it could be -4, because 4 times 4 is 16, and -4 times -4 is 16. Try number 3. Pause the video and see what you get for number 3. Okay, we don't have the c squared isolated yet. It's 3 times that. So I'm going to divide both sides by 3 and get c squared equals 12. It equals 12. Now I take the square root of both sides and I get c equals, well, the square root of 12. That's a little bit of a sticky one. That doesn't have like a perfect number, right? It's not 3 times 3 and it's not 4 times 4. So when that happens, we're just going to leave it as square root of 12, but we have to put in front this plus minus sign to show that we have the positive square root of 12, which is like 3.4, or the negative square root of 12, right? So when we can't find it evenly like we have been able to in the past, we're just going to leave it. Number 4, we would divide both sides by 5, and x squared equals 20. X squared equals 20. Now we can take the square root of both sides because that x squared was by itself, and I get x equals square root of 20. Well, 4 times 4 is 16, and 5 times 5 is 25, so it's like somewhere in between there. So we're just going to leave it and make sure we put the plus minus sign out front of the square root of 20. All right, and that's, again, we're trying to isolate the squared part. One more. Let's take a look at one more problem. See what you get. This is a challenge. First step is to subtract 42. We need to move the constants first. Subtract 42. It's just like if this was just a t. We would move the 42 first. 4t squared equals 25. Now we divide by 4. Divide by 4. And we get t squared equals, and we're going to leave it as 25 over 4. T squared, last step then is to take the square root of both sides, meaning t equals the positive negative square root of 25 over 4. However, when we have a fraction in there, we can actually say it's the square root of the top over the square root of the bottom. What's the square root of 25? That's 5. And what's the square root of 4? That is 2. And we just make sure we put that plus minus sign back out on front like we're supposed to. And we get plus or minus 5 halves, or plus or minus 2.5. A lot of steps and a lot of practice involved in understanding how to solve these. So please take the time today to make sure you try the packet practice problems and reach out if you have any questions at all. Until next time, everyone, stay safe.